Welcome to Algebra with Miss Swartz. It's our first video today, so we're going to get you used to it a little bit. It's a pretty quick, simple lesson. I know you guys have done equations before, so we're going to work through this. I have written down here, anything highlighted should be written down. There are some vocab words today that I would like you to write down, and it's a little bit of writing, but I think it should help you a lot. Your journal does have these vocab words in it, so if you would like to use that, it can be found on page 4 in your journal, some of the vocab words. So if you want to write them down in there, that's fine. If you just want to put them in your notes, that's awesome. But one way or another, they need to be written down. Then any example that I do, you should have written down as well. And any example I ask you to do, please write down. Awesome, let's get started here. So first vocab word here, pretty simple, is equation. Okay, equation is just a mathematical sentence that uses an equal sign to show that something's equal, right? So we have something like 4x equals 16. We know that those are equal is what it's telling us. And yeah, we might be asked to solve for x here, but we just need to know what an equation is. That's super basic, but it's highlighted. Please write it down. Okay. This one you may think, what, Miss Swartz, that's really wordy. A linear equation in one variable. Okay. What we're going to be working with for the first chapter, for sure, is linear equations in most of the year. Actually, is linear equations. You may recognize the word linear. You may not. If you can see, the base of the word linear is line. These types of equations that we're talking about right now would form a line on a graph. So what it says is it's an equation that can be written in the form ax plus b equals 0. And we're going to go more into that, what that looks like on a graph. But for now, just write it down, and then we will keep diving more into it. I just want to get those words out to you so you're starting to see them more and more. The next is solution. Obviously, a solution to an equation is just going to be something that can make the equation true. I'm trying to scroll down a little bit here. So anything that makes the equation true would be a solution. Inverse operations are going to be very important to us. Inverse operations are two operations that undo each other. So addition undoes subtraction. Subtraction undoes addition. Some more examples of that would be like multiplication and division. Roots and exponents are actually inverse operations. I think you should be able to see this bottom one down here. Sorry if that's in the way. Equivalent equations, we won't see that too much, but equations that have the same solutions would be considered equivalent equations. So that's good to know. Any equation that has the same solution, those are going to be considered equivalent equations. All right, now we're getting into the big stuff, the core concepts. Every day we'll have what is called core concepts. So these are things you really have to know. Luckily today, you probably already know these core concepts. So our first core concept are the addition and subtraction properties of equality. So you can read through these. Essentially what it's saying is that if A is equal to B, then if I add anything to A, I can do the same to B, and they're still going to be equal. Same goes with subtraction. If A is equal to B, I can subtract the same thing from both sides, and they will still be equal. So what this boils down to is, remember when we're solving equations, when your teacher would say, if you do something to one side, you have to do it to the other. This is where that comes into play. This is why the addition and subtraction property of equality. If I do something to one side, so if I take A and I add C to it, to keep the balance, to keep the equation equal, I would have to do it to the other side as well. So you can write these down. Some of the words sometimes get a little wordy, but the algebra is really good. Which leads us into the next core concept, which is very similar, the multiplication and division properties of equality. Along the same lines, if A is equal to B, if I multiply C times A, well, to keep it equal, to keep it balanced, I would also have to multiply C times B. Okay, so I can multiply anything as long as it's the same on both sides, because that's going to keep it equal. In this case, C cannot equal 0, as well as with division. And we'll talk about why that is moving forward. But division works along the same lines. If A is equal to B, then A divided by C is equal to B divided by C. They're the same. We're going to give some examples of what this looks like and how this works. You may think the core concepts aren't necessarily applying, but they are. And it's good to know these properties here, the multiplication, division, addition, and subtraction property of equality. It's why we can do what we do to solve equations. So we're going to start in on some examples here. Notice the directions. It says solve each equation, justify each step, and check your answer. So remember, if you think back to solving equations, our goal is to get the variable alone. We want to get x all by itself. To do that, we need to use inverse operations. We talked about those at the beginning of the lesson. Inverse operations. Remember, inverse operations undo each other. So if we're looking at this equation, x minus 3 is equal to negative 5. We already know these two things are equal. We're trying to find the solution of the equation. You may already know it in your head, but I still want you to show the work. I still want you to justify your step, and I still would like you to check your answer. You may think, Ms. Schwartz, that is way too much work for this easy problem. Why am I making you do it now for this? I'm making you do it now so that when it gets harder, which it will, you will know exactly how to do that. So the inverse of subtraction is addition. So what we're going to do to get rid of this so that we can have just x on that side so we can figure out what x is, we're going to do the inverse operation here. We're going to add 3 here. But remember, our addition property of equality said that if I add 3 to this side, that's fine, I can do that. But I would have to remain equal, add 3 to this side. So whatever I do to one side, I have to do it to the other. So this purpose is the addition property of equality. So negative 3 plus 3 is 0. What do I have left on this side? X. And now I just have to figure out negative 5 plus 3. Negative 5 plus 3, those are different signs, so I'm going to subtract. I would have 2 and keep the sign of the larger absolute value, which would be negative. Now, it says check my answer, okay? So if I'm going to check my answer, what does that mean? That means when I plug x in here, it needs to be true. So if I plug negative 2 in where x is, okay, I have subtraction. I'm going to keep change. Does negative 5 equal negative 5? Yep, we are good. So in the same way that I just did A, I want you to try B. Okay, show me the steps for inverse operations. Show me how you solved it. Show me checking it. Show yourself checking it. Okay, let's do another example together on the next page. We're going to do 2 together because it's fractions and I know that it gets everyone excited. I'll have you do 1 on your own. But look here, we have g minus 1/3 equals negative 2/3. This doesn't change anything because we have fractions involved. We're still going to work the same way, inverse operation. So I'm going to add 1/3 to both sides because I'm trying to get g alone, and that's the inverse of subtraction, adding. So if I do it to this side because of my property, addition property of equality, I'm going to add it to the other side. So I have g is equal to, because these cancel, now I have negative 2/3 plus 1/3. So I have different signs. I'm going to subtract. 2 minus 1 is 1, and luckily we had common denominators already. The larger absolute value is negative, so g is equal to negative 1/3. I should check this. So I'm going to plug negative 1/3 back in. Keep change. So I have negative 1/3 plus negative 1/3. That would give me negative 2/3, which does equal negative 2/3. Good to go. So try this one on your own. Yes, there's some decimals, but it works very similarly. We have one more page of examples. We had to throw some multiplication and division in there. So here I have division. So the inverse of division is multiplication. So I'm going to multiply by what here? Well, if I'm trying to get rid of it, I'm going to multiply by 3, because 3 over 3, or 3 divided by 3, is 1, which gives me y by itself. The multiplication property of equality says, okay, you can multiply anything on this side, but to keep it equal, you better multiply it over here as well. So y is going to be equal to negative 18. If I'm going to check that really quick, negative 18 divided by 3, does that equal negative 6? Yes, it does. Alright, so you're going to try 5 on your own here. Make sure you check your solution. When you're done with that, come show me your notes. I want to look at them. I want to make sure that you're taking good notes, and then I will tell you the homework at that point. Thanks for watching. Have a great day.